Different materials conduct electric current at different rates. For example, copper wires conduct electric current better than aluminum wires. In this lesson, we'll be looking at properties of a material that have to do with the conduction of electric current. Recall that resistance is a measure of the opposition to the flow of electric current in a circuit. It is like the degree of constriction in a pipe carrying water. The tighter the constriction, the higher the resistance to the flow of water, and the harder it is for the water to flow through the pipe. There are four factors that affect the resistance of a piece of conducting wire: the length of the wire, the cross-sectional area, the temperature of the wire, and the material the wire is made from. Continuing with our water analogy, the longer the pipe, the longer it takes for the water to flow through the pipe. So we say the resistance to the flow of current is directly proportional to the length of the wire. If we expanded the pipe, water would flow more freely in the pipe. That is, the bigger the cross-sectional area, the less the resistance. We can write that mathematically, as resistance R is inversely proportional to the cross-sectional area A. We can combine these two relations to get R is directly proportional to L and inversely proportional to A. Now we can introduce a constant of proportionality. If we call our constant rho, the relation becomes R equals rho L over A. Rho is known as the resistivity of the material and depends on the exact kind of material the wire is made from. The SI unit of rho is ohm meter. The greater the resistivity of the material, the poorer its ability to act as a conductor of electricity. So if we have an electric circuit like this, you will notice that it is not glowing. This is because there is no flow of electricity in the circuit. If we place silver in the gap in the circuit, you will notice that the bulb lights up. We can say that silver has a really low resistivity. Now, if you place the material like glass in the gap, you will notice that the bulb is not lighting up. This means it is not allowing electric current to pass and thus has a high resistivity. Finally, if you placed a material like silicon in the gap, you will notice that the light will glow faintly. This means silicon has a resistivity that is higher than silver but less than glass. This means the resistivity of silver is less than that of silicon, which is less than the resistivity of glass. Another way we can talk about opposition to the flow of current is to talk about the conductivity of a material. Resistivity measures the material's opposition to the flow of current. Conductivity measures the ease with which a material allows the flow of electric current. So, electrical conductivity is a measure of the amount of electrical current that easily flows through a material. It is represented by sigma and is given as sigma equals 1 over rho. And the SI unit of electrical conductivity is Siemens per meter. Keep learning.